Today's lesson is an exploratory lesson, or constructivist approach, where students are trying to find the equation for surface area of a cylinder on their own without being told in a direct fashion by me. So it's not me saying the formula is this, use it. It's them finding it on their own and then using it. To me, today's lesson is not like the mechanics of the surface area formula. Like, it's not about me checking if they can multiply with decimals. That's not what I'm looking at. I'm asking my students to grapple with these high-level ideas, the big ideas. Which parts of these two expressions are exactly the same? Nothing's different about them. 7 parts. Who are you? Which of these two parts are exactly the same? Just look at them. What's the same?
Pi.
The pi part, exactly. So these pi parts that just underlined in red are just the same. Good. Now, moving on, 7 of clubs. Tell me how this green D and the 2 in R are related. 7 of clubs, who are you? Oh, sorry, pass. 6 of spades. Jamel, how is the D related to the 2 and the R? What does the R stand for? Okay, how can you relate a radius to a diameter? Ooh. Other way. Is the whole thing. That makes the radius half. So, okay, work with that. Why does 2R then make sense? 2 times R. Why would that make sense? Ooh, there you go. 2 times R equals your D. So these are the same formulas. The pi parts are the same, and 2 times the radius is just your D. So what I would like you to do, take your think tank paper, leave it think tank side up, and put it on the corner of your desk. This is your one and only hint from your teacher for this period. So leave your think tank paper out, think tank side up. You're going to need it at some point in this lesson. You'll be like, oh. And I'll be like, look at your think tank. Look up. If you'll notice, each of these labels is scotch taped on. You can feel free to remove the scotch tape. In fact, it's kind of a hint. You should remove the scotch tape. Just don't rip the label off. I'd like to use them again. So please don't just rip the label off. You could definitely take it off. In fact, you should.
The strategy was height by circumference would equal the surface area of the cylinder. And the reason is because
the whole cylinder?
Of this part.
Which part?
Bottom and
Part around.
Okay. Is that it?
And then you have to add the top circumference and then you're done.
Top circumference?
Top and bottom area.
What are we finding?
Yeah.
I agree with some of what you said. What you said about the middle piece, I'm not going to argue with. It's correct. But there's something else you're missing. What else is part of? Huh? Surface area asks us to do what, Jamel? What is a surface area?
Measure
the top,
around.
yes. But we did
You need the top. You're right. How many? Is it just one top, or is there? Okay, so you need 2 tops and that middle piece you just talked about.
So we found the length and the width of this, and then we got 20.
You got that? Yeah. Yeah. We're here.
Oh.
Tell me about the next piece.
So area equals pi r squared. So we had to find the radius of this to get the whole idea. So we did area equals pi and then 3.2.
The only thing I'm going to say real quick, how many of these circles are there, Jasmina?
2.
Did you guys multiply by 2?
Oh.
Fix it. Hurry up. Hurry up. Hurry up. Start it off. Talk to me a little bit about what your initial strategies were. What did you do to start off?
Our initial strategy was to find the area of the label, which was pretty
Hold on 1 second. You say area of the label. Like, I'm looking at a can. What did you do with the label?
We took it off,
And what did it look like?
it looked like a rectangle.
It certainly did. It certainly did. It looked like a rectangle. Then keep going.
Then we did length times width.
Well, okay. So you had a length here and a width there, and you found the area of the rectangle. I agree with you. Good. Let's pick it up with someone new. 9 of hearts. Jump in.
Okay. So after that, we found the length, and the length was 21.
Yeah, let's leave the calculations because some of these cans are slightly different, so they won't make sense for each table group. So let's just ignore that. Like, the idea is this: length times width of your label.
So
and then what next?
And then we moved on to the base of the can.
Which was what type of shape?
A circle.
A circle. So if we're calculating surface area, we have to add in those circles. And how many were there, Trayvon?
2.
There were 2. So I'm going to put a times 2 here.
So and then we
Stop right there. Stop right there. So far, you guys are developing this formula that starts off as surface area equals, looks like length times width, and then you have a plus, and then through a space. How do we find area of circles? I forgot. How do we find area of circles? Circumference formula for area of circles? It's all right. You have it right. So you just.
Yeah, is pi r exponent 2.
Pi r exponent 2 or pi r squared. And Veronica, how many circles were there again? 2. So good. So we're going to have this 2 out in front. And good. When you guys did your think tank and we had this 8 pi centimeters circumference and I unwrapped it, what was the length of that? The same, 8 pi, right? 8 pi centimeters. So same idea. If the label we don't have, when we unwrap it, if we know the circumference, when we unwrap it, it'd still be what? The same, right? So even though you don't have the label, you know that the circumference when it unwraps is your length. Can you find circumference somehow? Do you remember how to do it? Do you have your, look back at your do now. Look at your do now. Do Jonathan, so it's right here. Okay, you don't have it filled out, but it's one of these two. So what's happening? Do you guys understand the strategy going on right now?
I'm kind of confused.
Can you think back to your think tank when we had that bracelet and we unwound? It was 8 pi centimeters, right? The circumference. What happened when we unwound the bracelet? The length of that was what, right? 8 pi centimeters. So same idea. What's going to happen? You had your label. The label represents what measurement of a circle or the cylinder when it's on. You got it. Circumference. And when you unwrap that circumference, it's still the circumference, or unwrap the label, it's still the circumference, right? But we just don't have a label. But you know that when you unwrap it, that length is your circumference. Can you find circumference? Is there a way you can do it? What could you do?
We already did it pi to the 7. We find the diameter, and then we times it by 3.14, and we got 21.98, and you round it to 22, times it equals 176.
So okay, you got 22 for your circumference? That's good. Now how are you going to use that to find the area now of this piece? Remember the shape.
You're going to times it by 8.